Hi guys, how are you? I hope all you are doing good. Welcome to the Learn Code Easily. So today we will solve one more question of the stack and we will continue with our stack series. I hope you have all accessed the stack series. If not, try to access it. And before moving to the next video. So if you like the video, please like it and subscribe it and comment as well. So we will move towards our next question. The next question is 1472, that is design browser history. We have solved the previous question of all the easy and the medium level question. So this is the next question from the last question. So here it is given that we have a four function. First is a init function, second is a visit, third is a back, and fourth is a forward. So what is init initialize the browser history, and the widget will help you to visit from to the next page from the current page, and back means you need to go forward in the backward direction, and forward means you need to go in the forward direction in the browsing history. So as you know that we have a Google history, so here there we can go from back to fourth, and if you click on any of them, then we can move to the we can visit to any of the page if we click to any of the history. So the same logic we need to apply here. So here what it is given, here it is given that we have a browser history. So here we will take, we have a function init, so here we will initialize our browser history. Then we have a visit. So in the visit we need to just store the browser history into our one of the data structure. Now the question is what data structure we need to use here. So before moving to the data structure, let's take a look at the example. So here it is given that browser history. So this initializes our browser, you can say the browser history as Leetcode. Then we have visited to Google, then we have visited to Facebook, then we have visited to the youtube.com. Now we need to go back. Now we are on the youtube.com. Okay, so if we click on the back button, then we will move to the Facebook, and that is the output. Now we have to visit the now we need to again go to the back. Now we will go to the google.com. Okay, now we need to go forward in one step. So this is again facebook.com. Now again we need to visit, what we need to visit, we need to visit the LinkedIn page. So this is the current page, and here it is given that when you visit any of the URL, it clears up all the forward history. Means previously I had Leetcode, Google, Facebook, YouTube, but when I have moved to one step, then I reached to Facebook, then I reached again one step, I reached to google.com. Now when I move to one step forward, I have again reached to facebook.com. Now when I visit the URL of linkedin.com, then youtube.com will going to be what? It is going to be clear, because here it is given that when you visit any of the page, it visits the forward history. So instead of youtube.com, our linkedin.com will be inserted here, or you can say that LinkedIn URL will replace the YouTube URL. Now we need to go. Now we have only Leetcode, Google, Facebook, and LinkedIn. Now we need to go forward direction, one step forward, two step forward direction. But here we do not have any URL which we can move, because we are at the end, we are at here LinkedIn, so we cannot move. So we need to simply return the LinkedIn one. Okay, now we need to back from LinkedIn. I can go to the back because I have a Facebook. So where what I need to return, I need to return back is the google.com. So I had a lead code, then I reached to Google, then Facebook, then YouTube. From YouTube I have reached to Facebook. From Facebook I reached to Google. From Google I again reached to Facebook. Now I am on the LinkedIn page. Now I cannot go forward. Now I need to move in the backward direction, that is the google.com. And again if I will move to the backward, it is a leadcode.com. Facebook, we have a Facebook, we have a Google, we have again Facebook. And when we move to the next page, so here it will be LinkedIn. But if we move to the backward direction, here it is given that we need to visit one. Okay, So here we need to visit two step forward. So we need to move two step forward. So here to here it is google.com. Now again I need to move to the backward direction, so I can move only one step backward, that is a leetcode.com. Because I do not have 7 history, I have only one history in the backward direction, so that only I can traverse. So I hope it is clear. Now here what I will do, I will take the count of the history as key, and value is the browsing URL, okay, or you can say the website URL. So here I am going to use the dictionary here. So with the logic I will explain you what I am doing here, line by line. So it is clear that it is, I hope you are clear that why we are taking a dictionary, because we need to access the history in big of one time, and that can be only done with the help of dictionary, or you can say hash map. So here I have taken the dictionary. You need to take the better name convention. Now this is a count variable, or you can say the count of history, but I'm taking here count. So this is done. Okay, now and I need to initialize our dictionary, or you can say the home browser dictionary, okay, with the home page. So let's take as one. So this is our first history. Okay, now when I need to visit any of the next history, any of the URL, then what I need to do, I need to increment my self counter. I need to increment my count and self of dictionary count, and here I will insert the URL. Okay, now this is done. Now if I need to back, and if I need to okay, so let it be at easy. Okay, now if I need to go in the backward direction, okay, so what I need to do here is I need to go in the backward direction. So here I have take one of the one of the resultant, so you can you can call it as a result. Okay, now right now you need to ignore why I have why I have done this. So count of back step, I need to go in the backward direction. So self dot count, so self dot count, assume that we have this one, uh like who, like I have a FB. Okay, now I have Google, now I have WhatsApp. Okay, so I have this one. So if I am here, I need to go two step backward, so I need to go at the FB. Okay, it is correct. So self dot count will be, at this point it will be 1, at this point it will be 2, at this point it will be 3. Now self dot count greater than 1. Why? Because if I need to go in the backward direction, so self dot count 3 is greater than 1, it is correct, and it will be incremented, it will be decremented by 1, so it will be 2. Now count of step, how many steps we have gone in the backward direction? 1. Now what will be the resultant? Resultant will be G, correct. Now 2 is greater than 1, it is correct. Now count will be 1, count of back step will be 2, and I need to move only 2 step backward. Okay, I need to move only 2 step backward, and it is 2. What will be the resultant? Resultant will be FV. Okay, now it is 1. 1 is greater than 1? No, it is not, it is wrong. So what will be the result? Result hold the FV, and it is correct. I hope you understood why I have applied this logic. Okay, and why I have initialized result as this one. Assume that if I have to go assume if I have to go in the backward direction, assume that I have visited, so result here I can initialize our result variable as empty. So I can initialize as a empty as well. So let's see what will be the effect. Now I need to go in the forward direction. Assume I need to move in the forward direction 2 step. So and my counter is at 3. Okay, now my setup dot count 3 is less than length of 3, so it is wrong. if it is wrong, I need to simply the last value, because if I cannot move in the forward direction, then I need to return the current page. What is the current page? Current page is self.d. So self.d is this one, and what is count? Count is 3. So this will give me the this one result, and I need to return this one. So here I do not need to first initialize empty, and then I will check that if my val is empty. If my val is empty, or you can the result is empty, then you need to return, this one. uh, then you need to return. Okay, so this is also one of the way, like if it is empty means you are at the last step, you cannot move in the forward direction, that's why you are returning the current page. So I have directly initialized this one here, because I do not need to write more numbers of line. Okay, so I am making it shorter. So that's why I hope this is clear. And so here we can move in the forward direction, we can move in the backward direction. And if it is, if I need to move in the next page, if I need to move if I need to visit any of the page, then I need to simply do this one. Okay, so if I need to in the backward direction, assume that if I need to move 7 step back, 7 step back, so I can only go till here, because here I have applied the condition. Okay. So, and assume that if I am already at this position, and I need to go in the backward direction, so I cannot come inside this loop, and I need to return my current page. So for that I need to initialize our result. Okay, now this is it. Now this is result. Okay, so here I have given the result variable. Now one of the thing here we need to notice, here we have missed one of the point, because I have applied here self.count does not equals to self.max value. What is max value? So if I need to visit any of the page, then I need to next clear the all the forwarded history. For that I need to maintain one of the max variable. What max variable tells? What max variable tells me that if you have something, this one. Okay, and your counter variable, and you have moved from and you have come inside this loop, and you have moved two step backward. Now you are at the G. Now here you have to visit a next URL, that is a LinkedIn. So here it is given that visit URL from the current page, and the current page is G, that is Google. I will move from the current page to the next URL, that is a LinkedIn. Means all the forward history will be cleared. So instead of W it will be L, and here it will be nothing. It will means logically it will be like this one. Okay, but for understanding what I am doing here is I am breaking into 3-4 steps so that you can understand. So here it will be LinkedIn, because I need to visit one of the next URL, that is a LinkedIn. So here it will be LinkedIn. So I am not clearing the next upcoming or the next forwarded history. So it is LinkedIn. Okay, now what will the count will be? Here the count will be 3. Here will be the count will be 3. So if the count, so what will the max value will be? Max value will be 3. So what is the use of this one? Okay, now you need to think what is the use of this one. The use of this one, if you will go in the forward direction, so according to you, you have already u URL as well in your dictionary. But logically what it is given the question that you cannot move, you have cleared the next forwarded history, but we are not clearing it. So we need to maintain one of the max variable that tells that you cannot move forward because the forwarded history have been cleared. but we are not clearing it. Okay, so we are maintaining one of the, because if we are going to clear it, then we need to traverse, then from here, then from third position I need to clear all the forward history, so I need to do big of n time. So for not doing big of n time, just making our solution big of n, so what I am doing, I'm maintaining one of the max variable that help us not to clear the remaining history. Okay, so max variable help us to profit us, to help me to recognize at which point I need to move, till which point I need to move, and from there I cannot move it. So that actually tells by the max variable. So I hope this step is clear in your mind. So what it will be tell. So assume that my current pointer is this, because when I have inserted the LinkedIn, my current pointer will be, my count variable will be 3. Okay, now I need to move one step forward. If I do not maintain any, if I do not write it, so what my logic is my self dot count less than self of d length of, so this will be 3 less than 4, and it is correct, I can move. But when I have applied this condition, self dot count does not equals to max variable, means my count is also 3, max variable is also 3, I cannot move in the forward direction, so I can simply return my LinkedIn, that is the current URL, because it is given that I need to move in the forward direction, but logically I cannot move it because the next history have been cleared. So for that I have maintained one of the max variable. So let's initialize that. Let's initialize the max variable. Uh, so here you have taken a dictionary, you have taken the count, you have taken the initialize your dictionary, here you have max variable, and here we are increment the count, and we are keep tracking of the max variable, so that we do not need to clear our forwarded history every time. Okay, that will, if we do, then it will be big of n square time complexity, whole history, whole, like moving forward, backwarding, traversing, it will be all be big of n square time, so I need to do in a big of n time. So let's try to run it, I hope it will be. So let's try to run what, let's see what it is given. It is given that self dot d, uh, result dot d does not, so it is some error, so let's try to figure it out. Okay. Okay, it is so everywhere you need to write self, first thing, self dot d and self dot count, self dot max variable. Here what it is missing, here self dot count is self dot, okay, it is also correct here. So let's first test the and give an example. So it is giving me that one is not present, one key error one. So here what it is given, one is not defined, so here I have not, okay, so here I have not written the self. So let's try to submit right now. I have directly, okay, so it has been submitted. Let's first try to run. Okay, so here we haven't initialized, here we have written the self dot, we need to write the self dot count, but here we have written the count variable, so that's why it is given that one is, because we need to, here we, our key is one, but here we haven't write self dot count. Okay, so it is wrong. I hope this is clear, because this is clear, and here we are, every time we are doing big of one, big of, every operation is big of one. So for n, it is big of n. So the overall complexity is big of n, and the space complexity is big of n as well, because here we need to, we are storing one of the home page dictionary. Okay, I hope you are clear. I will meet in the next video with the next video. Okay, guys, and please like, subscribe, and comment as well. Till then, bye bye. Take care. Bye.